Hey guys, this is Reed here, and this is going to be the first of hopefully many Java tutorial videos. Today I'm going to be starting with, I think this is a relatively easy problem, and this one is called Interlocked. For Interlocked, what you have to do is you have to make sure that three strings that you were given match the following four criteria. I will also have on the description a link to download the problem statement and the sample input data so you can try this out on your own if you wish to. But here's the four criteria. All of the characters in the first string are contained in order but not necessarily consecutively in the third string. All of the characters in the second string are contained in order but not necessarily consecutively in the third string. And letters appearing in both words do not have to appear twice in the interlocked word. And letters that appear more than once in a single word must also appear more than once in the interlocked word. So those are the four conditions that you have to make sure your strings match. So for this problem, I will be using the imports from java.io.file, java.util.scanner, and java.lang.system, which I'm using a static import for, so I don't have to do the system.out.println. The data file will be interlocked.dat, and then right here, I'm picking up the first two. This is just a template file, but basically I'm taking the first integer, which will be the number of strings you have to compare, or the number of test cases you have to compare. Each test case has 3 strings. I also have down here the main method, which just makes a new interlock. This is just kind of easier for you to use as a template if you want to make it, I guess, cleaner kind of, and it makes it easier when you have to call multiple methods and write harder problems. I will also upload this template file right here to some file sharing site so you can download that as well. And I might also upload the answer. To start off, what you need to make sure you do is you got to read in your input data. I would do string s1 equals send.next, string s2 equals send.next, and string s3. There you got your first 3 strings. Now what I like to do, which kind of makes it easier to read and makes it easier just to solve the problems, is I like to put it so that you call methods basically to solve the problem. You could solve this problem in copy and pasting for loops here, but it's probably easier and cleaner to call methods to solve it. So I'm going to be calling a method called isLock that will take 3 string parameters. One more thing to point out while I'm doing this, making these methods, is that right here I'm using the default class, which typically you could also put public here, public boolean, but you do not have to when you are doing like context Java, because you know that you're going to be calling it, it's going to be on the same package, same class, it's not really a big issue. So I just like to leave it off because it makes it faster. In context Java, the most important thing is speed. Well, accuracy is more important than speed, but it's important to be quick with your solving a problem, so less characters you type, faster it is. Don't go too short though when you're like making variable names or method names, because sometimes if you made it just a 1-letter variable name or 1-letter method name, you might get confused when you're trying to debug. It's nice to have them clear and concise. Run count here is very long, which you wouldn't make that in a regular thing, but since I have a template that already made it, it's okay. But when you're on time, you don't want to do that. Now what I'll call here is the last line that I have to put in this little method here, the run method, which is basically my main method, is just out.println isLock s1, s2, s3, question mark, which is using the tertiary thing, which the first condition right here will evaluate to a boolean because it returns a boolean. Then if that is true, it will print out yes, and if it's false, it will print out no. This is basically a shorthand way of writing the if statement. That would be like, basically you could say if isLock s1, s2, s3, then you out.println yes, all caps, else out.println no. That's a lot of characters you have to write, and it's like 2 print statements, and else and if. It's very not dirty, but it's more confusing to read if you're trying to debug it or something. So writing your print statements with if it's just a simple yes or no, using something with tertiary, which is isLock s1 boolean condition here. If it's true, prints out the first part, colon, prints out the second part if it's false. Makes it nice and easy to work with. Now, typically you wouldn't need to have these two methods, isLock and check, but because you're comparing two strings twice, and it's basically the exact same comparison, what I will do to make this one a little bit easier to read and less copy and pasting of code is just do return check S1, S3, which are the two strings you're comparing. Just make sure you know S1 is the first input string, S2 is the second input string, and S3 is the string you're comparing S1 and S2 against. So right here I do check S1, S3, and check S2, S3. Now I'm using the double and signed just because if one of them fails, you don't need to worry about checking the other side, but it would also work with just if you put the single in. But it's more efficient and faster like that. Okay, first thing you need to make sure you check for is what happens if S2 is greater than S1.length. If S2, or not S2, if S1 is longer than S2. If S1 is longer than S2, then you'll never actually have a match because S1 has to have every character located in S2. So if S1.length is greater than S2.length, you can just return false because it will never work out. Now we're going to actually work out some for loops. But the first thing, first thing, you're going to make sure you have all your variables, have a plan. I already have a plan of what I'm doing because I read the problem and I have in my brain the idea of what I want to write. What I'm going to need to make this work is I need an index. That'll be the last index found. So I'll call it last index. This will be the last index found. I'll set to -1 just so I know it's out of the way and it works out. Then what you're going to need is two for loops because you have two strings you're comparing. You got to go through each string, cycle through, make it work. So I'm going to name the outer one outer because I will need to call this one in future lines of code to make the code work. So I'm just doing for I equals 0, I is less than S1.length. So I'm calling S1 as the outer loop because that's the one that's actually getting compared to. You may be able to write it using the other way and having the S2 being the one in the loop, but it works better, at least for me, this way, or at least this is the only way I did it. And then there you go. So now I'm going through each of my strings. The trick here is it's actually not going to, you don't want to set Q to 0 here because it's 0 only for the first one. After the first attempt going through, when you're finding in your answer string, the one you're comparing everything to, you want to set it to the last index plus 1. Because the last index is the last point you located a letter in the alphabet in the comparison string. What you're going to do now is go if s1.char at I is s2.char at I, that means you have found the string. So now you know the character that is located at s1.length, which real quick these are my two strings I'm using for the first data set. So bit and bointe. Those are the two strings I'm comparing. And you can see B is in B, so that's first, and there's an I. You go through, you find an I. You go through, you find a T. And then it means this one is locked with bit. You also had to compare with this one the 1, which is the S2 from here. But then you'll go through again, you go O and E. So that's just a little something you can see, so you can see what I'm actually working with. This will be all online, and then you can download it and look at it while you're working on it. What you want to do when you know you found one is you need to set your last index to what Q is. You don't need to do the increment plus 1 because you do that when you assign Q the next time you loop through the loop, the inside loop. After you assign Q, you don't need to keep checking for more of them, so you just hit continue. You don't hit continue, you type continue outer. Because what you want to do once you find that the two characters match here, and they're in different, oops, that's not right, s2.char at Q. There we go. What do you want to find out whenever you get to s1.char I equals s2.char at Q? You know that they found it, so B, they're both 0, 0. Next time you want to start looking at O. So you set last index, and you can continue outer to work on the next char, which would be I. So you check I, oh, there I found an I. So now I do that again, keep looping through. What you need to do now, though, is what happens if you didn't find it? Well, if you didn't find one of the characters in S1, then you're not going to be able to ever have a locked string because you had to have every one of those characters. So if the for loop ever gets out of it and you finish the for loop, meaning that you never continued inside of it, you can just right here go return false, because you know you'll never get a match. You don't have to keep checking the s1.length plus 1, anything like that. You don't have to keep checking. If you don't find a B, you don't need to check I or T, so we just return false, and returning just gets you right out of the method, and you don't have to worry about it. So what happens though once you've finished all of the continues, you continue, and you got past T and you found everything. You get out of the for loop, and you just go return true, and that means you found the match. And that is the answer to the problem. It's pretty simple. We'll compile right here and make sure I don't have any errors. And yep, if you look at the answers, here I'll print the strings out real quick so you can see them. S1 plus space plus S2 plus space plus S3. We'll compile again. And there we go. Bit 1 and BOINTE. You see there's a B there. You see there's an I, and you see there's a T. Everything resets. You see there's an O, N, and there's an E. And you can keep going, check the other ones, they all work out. This one doesn't work because you see a B, you see an I, you see a T. So bit is locked with this one, but then you gotta check one. You get an O, you get an N, and you start here, and uh-oh, there is no more E in the string, so then he doesn't get a match. I will be trying to upload these Java tutorials on Mondays and hopefully Fridays as well, and there'll be 2 a week. I'm not really sure what level of difficulty I need to be doing problems for, so just send me a message or put a comment on this YouTube video and I'll adjust which type of problems I'm doing, either make them a little bit harder or a little easier. This one I kind of assumed that you knew the basics of Java, and it's just to kind of help with some algorithm tips and just different ways to solve the problem efficiently or inefficiently. I'm not saying this is the best way to do it, but this is the way I do it, and I'm pretty sure it's a pretty fast way to solve it. Didn't take long to run, got it correct first try. That makes it an easy way to do. I'll be doing another one soon, and then that will be uploaded on Friday. Thanks for watching, and hope to see you again.